Hey, what's up? It's your old pal, Mr. Cook, and we're going through the Honors Algebra 2 Spring Final Review. So, yeah, let's get to it. Looks like we have a formula sheet that we can use. It's got a bunch of nice little formulas and a unit circle on it, and then also, our calculator. So, those are the things we'll be using to help us out. The actual final exam will be multiple choice. So, I think I'll go through the problems and I'll kind of reason hey, what would this look like if it was multiple choice? So I'm just kind of guessing, but probably pretty close to what it's going to look like. Anyways, first part's all on trig. So what's the sine, cosine, and tangent of the angle theta? So here's the angle theta, and to find the sine and cosine and tangent of that angle theta, we're going to use its reference angle. So the reference angle is the angle that's made, from the line for the angle, right? So here's the full angle. That moving radius that we have going this way, right? Whatever that line and the x-axis, so the closest x-axis make that little right triangle that we get right there. That's where we're going to have a reference angle. So this is our reference angle down in here, and from this right triangle, that's how we're going to put together all of the different ratios. Now, since we have this coordinate, negative 16 and 12, just like any other regular coordinate that you have, the negative 16 is an x value. So along the x-axis, this side right here is going to be that negative 16. And then the 12 is actually going to be the y value. So it's going to be how high up it is from the x-axis at that point, which is the length of 12. So, if we use Pythagorean theorem, we can find that radius, r, and that'll help us to get, all the sides of the right triangle. Because once we have all the sides of the right triangle, we can find all of these, trig ratios pretty easily. So, you use Pythagorean theorem, or you can use the fact that this is a 3, 4, 5 triangle, 3 times 4, 4 times 4, so this will be 5 times 4, or 20. And, that's how you get the missing sides. Now, from this angle, this reference angle, the 12 is the opposite side, the 16 is the adjacent side, and then the 20 is the hypotenuse. So, when you put together all the ratios, it just depends on that. Sine is opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And then tangent is going to be the opposite side over the adjacent side. So we just make all those ratios real quick and we're good to go. So let's see, sine of theta is equal to the opposite side over the hypotenuse. So that's going to be 12 over 20. And then that obviously reduces down quite a bit. Those are both divisible by 4, so that'd be a 3 and a 5. And then we do cosine next. So cosine is the adjacent side, which is that negative 16. And then we divide that by the hypotenuse, 20. And then again, those are both divisible by 4, so that turns into a negative 4 over 5. And then the last one, tangent, is opposite over adjacent, so that's going to be the 12 over the negative 16. And those are both divisible by 4. That'll be a 3 over a negative 4, or negative 3/4. So how might this look on multiple choice? Well, they could always give you A, B, C, D, and maybe A and B and C would be the different combinations of the stuff. Like sine of theta is, 3/5, and then cosine of theta is, maybe they make this one wrong, so they give you the tangent instead, negative 3/4 or whatever. You just pick the right combination of the sine, the cosine, and the tangent. This might be one of those, select all that applies or something. Whatever. As long as you know how to find the ratios, you'll have the right answer. So if this part was pretty easy, all this stuff, then finding the right answer is going to be pretty easy too. Okay, next up, it says which angle has a cosine of negative 1/2 and a sine of 3, a square root of 3 over 2? So yeah, all we have to do is just go over to our unit circle to find this answer. So we would use our unit circle. And remember, cosine is negative 1/2, sine is a positive 3, square root of 3 over 2. So remember that on a unit circle, it even has it on the unit circle that, which ones are positive, which one are negative, and all that stuff. But really just got to look at the coordinate and remember that each coordinate has a cosine value, then a sine value. I remember that cosine comes first because alphabetically it's before the sine, right? Isn't it before the sine, right? And so is x and y. X and y are alphabetically in order, and cosine, sine, C and S are also going to be alphabetically in order. It's little things like that that you can remember that can help you to remember your unit circle. Anyways, so we had a cosine that's equal to a negative 1/2 and a sine that's equal to positive square root of 3 over 2. So we're looking for this coordinate, negative 1/2, and then square root of 3 over 2, because that's the cosine and then the sine. And let me just double check. I want to make sure that I got that right. Yeah, cosine is negative 1/2, sine is square root of 3 over 2. So if I go over to my unit circle, it looks like that's going to happen right over here at 120 degrees or 2 pi thirds. So depending on what what the multiple choice question is asking, maybe it's asking, it has it in terms of degrees. So maybe it has like 135. No, that's not correct. 120. Yeah, that's the one. So you select that one. That's your answer. Maybe they have it in radians. Just be comfortable with understanding that this combination of cosine and sine are going to give you, the answer of 120 in terms of degrees or 2 pi thirds in terms of radians. Okay, so that's number 2. Number 3, if cosine of theta is equal to negative 5 over 13 and cosecant is less than 0, what's the tangent going to be? Well, these two clues help me out a lot because it tells me like where the angle is going to be. So if I like draw my little XY axis, right? If cosine is negative, that's the x value. So I have a negative x value. And cosecant, I got to know that cosecant is really secretly 1 over the sine of theta. And if if cosecant is negative, that means that sine also has to be negative. So that means that I'm going to have a negative sine or a negative y value. Again, why do I, call cosine x and sine y? It's because, remember our coordinates from before, x and y, it's the same as the cosine and the sine values, right? So if this tells me right here that the cosine is a negative number, that means that I have a negative x. And then if it tells me that cosecant is also negative, that means that secretly sine is also going to be negative. Therefore, I have a negative y value as well. Okay, so where is this angle going to be? Is it going to be in quadrant number 1, quadrant number 2, quadrant number 3, or quadrant number 4? So, let's look at the clues. A negative x and a negative y. So that's x is to the left, y is down. So that means that it's going to be in quadrant number 3. So here's what I do. Once I figure out which quadrant it's going to be in, I just draw that quadrant real quick like this. I draw my little line just like what I did in number 1. And then I draw a right triangle directly to the x-axis. This is where my reference angle is going to be, theta. And this is how I'm going to be able to find the sine, the cosine, and the tangent for this, large angle theta that goes from 0 all the way over to there. Okay. Okay, so let's look at this, the information. Cosine is negative 5 over 3. Remember that cosine is adjacent over hypotenuse. So from this angle, the adjacent side is like right here. Okay. And that means that since the ratio is, negative 5 over 13, the negative 5 is going to be the adjacent side. So negative 5 for my adjacent side. And then the hypotenuse is going to be 13. And you might remember this from your geometry class. This is one of your Pythagorean triples. This is a 5, 12, 13 triangle. So that means that the missing side here is 12. If you didn't know that, right, you didn't know that Pythagorean triple, what can you use to figure out what that missing side is going to be? Remember, it's a right triangle. That's right, you can use Pythagorean theorem. So 5 squared plus x squared equals 13 squared. You subtract the 5 squared, you get 144, and square root of that's going to be 12. Now, here's the interesting thing. Since this side is pointing downwards like this, it's going below the x-axis, is also going to be a negative 12, okay? All right, so now let's put together our ratio that we're looking for. All right, so all that information told me what the triangle looks like. So now I'm just going to go ahead and do the tangent. So tangent is the ratio of the opposite side over the adjacent side. And from this angle right here, here's the opposite side, here's the adjacent side, and here's the hypotenuse. I know how to label all that stuff from geometry. And opposite over adjacent is going to give me a negative 12 over a negative 5. And the negatives cancel out, giving me just a 12 over 5. So 12 fifths should be my number for tangent. And you better believe that if this was, multiple choice, they would just have all those different options. A bunch of different options. One of them would be 12 fifths. So you just select 12 fifths as your answer. Okay, the next one, find the cosecant of 7 pi over 6. Yeah, this one shouldn't be that bad either. And here's why. I know that cosecant is secretly 1 over sine. So this is the same as saying the 1 over sine of 7 pi over 6. And I know what sine of 7 pi over 6 is equal to. If I go onto my unit circle, that's one of my unit circle numbers. Let's see, 7 pi over 6. Here it is right here. So the sine is going to be, let's see, the first one is cosine, the second one is sine. So sine is negative 1 over 2 when the angle is 7 pi over 6. So let's see what that means for our problem. So it means that, like, this part down here, sine of 7 pi over 6, that number is negative a half. So this is going to be 1 over negative 1/2. And, if you do this, 1 over a half or 1 over negative a half, you multiply by the reciprocal of the denominator, which is going to give you a negative 2 overall. So negative 2 is going to be the answer for number 4. And obviously they're going to be putting those values, of one after another, like for your multiple choice. You just got to select the right one. But you can also actually do this on your calculator. You can calculate cosecant. You just got to remember that it's 1 over the sine of the angle. So you can type in your calculator 1 over the sine of, and then you could do, square root, or I'm sorry, 7 times the pi of over 6, 7 pi over 6, and then hit enter. And sure enough, you'll get the same number, negative 2, so long as it's in radian mode, the correct mode, that you're looking for. Okay, so that's number 4. Now let's do number 5. So what is the sine inverse of the cosine of 5 pi over 6? Okay, well, again, if you've done enough algebra problems in your life, you know that you're supposed to, use your order of operations. Start with the stuff in the parentheses. Well, this is in the parentheses right over here, so I better do that part first. What is the cosine of 5 pi 6? That's another unit circle value. So I can go right over to my unit circle. I find 5 pi over 6, which is right here. And then I look at the cosine. The cosine of that is going to be a negative square root of 3 over 2. Okay, no big deal. Let's see what that means. So that means that this is now equal to the sine of, sine inverse of, and then I replace that cosine of 5 pi over 6 with the negative square root of 3 over 2. And, then I do my sine inverse. So now sine inverse, right? This is going to lead me to an angle measurement. So cosine or sine or tangent of an angle gives you a ratio of sides. So the sine inverse, the cosine inverse, and the tangent inverse of an angle, of a ratio of sides gives you the angle back. So this is going to be an angle that's going to be our answer, okay? So that's what we should be looking for. All right, so sine inverse of negative square root of 3 over 2. So now, what angle, this is what this question is saying. It's saying, hey, can you tell me the angle that has a sine that's equal to negative square root of 3 over 2? So I go over to my unit circle. Yeah, no big deal. I can find that. All right, so negative, the sine is the second number, where it has a negative square root of 3 over 2. There's one of them right there. Okay, so, 5 pi thirds or 300 degrees. And look, there's another one right over here, and that's at 4 pi thirds. So which one is going to be the one that I'm looking for, right? Okay, well, let's see here. If you, it could be either of those numbers or neither of them, okay? It could be 4 pi thirds, or it could be 5 pi over 3, because those are both true, right? But there's something actually really important with this sine inverse. So sine inverse is a function. And for something to be a function, it needs to make sure that it passes this thing called the vertical line test. So interestingly enough, if you take sine, just regular old sine equation like this, if you took sine inverse, what sine inverse does is that it turns it and makes all the x values y values. So basically, if this is sine right here, then sine inverse is going to look like this. It turns it on its side. It rotates at 90 degrees essentially. So it'll be like this. It'll go up and then down and then up like that and then down and up like that. That's sine inverse. And do you see that thing fails the vertical line test a lot, right? Yeah, it sure does, right? Like if I pass a vertical line, look at the y-axis. The y-axis already makes this not a function. So what mathematicians did a long time ago was that they realized, hey, sine inverse can't use all of, every single value to be able to, pass the vertical line test. So what they did was they chopped off part of it, okay? They chopped off part of the period of the sine function. So it just goes from a little part of it to another little part of it. So they just basically did about half of the period, for the function. So what happens is that it only actually goes from pi halves to negative pi over 2. And that allows it to now be a function again. and it allows you to tell like what's going on with the angle measurements and what values you can use for the angle measurements. And actually, I think I have those wrong. It's got to go like this. It like goes from 1, -1 there. Yeah, there we go. And then that's going to be a pi over 2. That's a negative pi over 2. There we go. That's better. Okay, so anyways, so we actually can only use values that range from pi over 2 to negative pi over 2. So, when we saw both of those numbers, 4 pi thirds and 5 pi thirds, we were actually wrong, okay? Because we can only use angle measurements starting at pi halves and going all the way down to negative pi halves, okay? So, the correct answer would be this guy right over here, 5 pi thirds, but it needs to fit in the range from pi halves to negative pi halves. So it's actually going to be this negative angle right over here, negative pi over 3, that should be our answer for this one, okay? And I know what you're thinking. You're like, oh my gosh, how am I supposed to know all this stuff if you didn't already know it? If you're like trying to review it right now, that might be something that you totally forgot. So that's why it's helpful to kind of piece this together using your calculator and your unit circle. I bet you guys could, get to this point where you're like, oh, I know what cosine of 5 pi 6 is. That's negative square root of 3 over 2. And then, from there, you can use your unit circle and you can figure out where these little guys are right there. Those are 2 possible answers. But here's how you can use your calculator to figure out exactly what it's going to be. Okay, so watch this. If I went back and typed in that original expression to my calculator, so sine inverse of the cosine of 5 pi over 6, and type it in, enter, I get some weird number. What is that weird number? Well, it's neither of these, right? But it is the number that I had, left over. It's that other one that I wrote down. It's negative pi over 3. Watch this, okay? Negative pi over 3. Okay, but how were you supposed to know that? How are you supposed to know that it's, negative pi over 3? So here's how you can use a multiple choice question to your advantage. So one of the multiple choice answers will be negative pi thirds, okay? So you're going through this problem, you're like, oh man, which one is it going to be? I don't know. And then they give you answers. You're like, A, negative pi thirds, B, 4 pi thirds, which is wrong. C, 5 pi thirds. They'll probably put that one on there too. Which one is the right answer? This one is, right? So here's what you can do. You just type the expression into your calculator, sine inverse of cosine of 5 pi over 6, just like that. And then type in these ones to your calculator. One of them is going to be that exact number. Is 5 pi thirds that number? No, it's not. It's 5.235, right? It's not negative 1.047. The only one that will give you the right answer is, it's going to be one of them amongst your multiple choice answers, and it's going to be the one that is the same thing in your calculator. So select that one. That's one of those ones where you can use the fact that it's a multiple choice question to your advantage. Okay, so anyways, that's number 5. Number 6, Joe rides a Ferris wheel at the fair. The graph shows his height above the ground throughout the ride as a function of time. What is the radius of the Ferris wheel? Well, the radius is going to be, the Ferris wheel is going to be like at a lowest point, and then at a certain point, it's at a highest point, right? So the height is going to be fluctuating. It's going to have a low point and then a high point. So if you can figure out the distance between the low point and the high point, if you just divide that by 2, it'll give you the radius, okay? So that's what we're going to do. We're going to figure out how high up the highest point is and how low the lowest point is. And then we're going to find the distance between it and divide it by 2. That'll give us the radius. All right, so going back over to this graph, it looks like the highest point is at 70. The lowest point is at 10. So let's find out what halfway between 70 and 10 is going to be. So, you just take the average of the two values, 70 plus 10 divided by 2. So that's 80 over 2, which is 40. So 40 is going to be the exact middle there, okay? So that means that, if we go from 40 to 70, that's going to give us our little radius, okay? So we found out where the halfway point is, and then from the halfway point up to the, the top part or the bottom part, That's our little radius. So 40 to 70 is 30. So that means that our radius for the Ferris wheel is equal to 30. And what are the units on it? Feet. So that would be our answer. Next, how many revolutions does the Ferris wheel complete in 3 minutes? One revolution is when it goes all the way around. So, it starts maybe at its lowest point and then go up to its highest point and then back to its lowest point. So on the graph, that will look like this. So from the lowest point to the highest point to the lowest point again. That one is one revolution. And then we just keep counting that so low to high to low. There's another one. Second revolution. Low to high to low. That's the third revolution. Low to high to low. Again, that's the fourth revolution. Low to high to low. That's the fifth revolution. So there's 5 revolutions in the 3 minutes. Well, actually, sorry, the 3 minutes ended like right over here, the fourth one. So, 4 revolutions in 3 minutes. Okay, how long does it take to complete one revolution? So that's going from low to high to low. So it looks like if we start at 0, it ends up at 0.75. So 0.75 minutes. And if 1 minute is 60 seconds, then that means that if we do 3/4 of 60, that would be 45 seconds. So either one of those answers could be on there as a multiple choice response. Okay, that's the end of the first page. I think I'll stop there. Yeah, I'll just do one page at a time. Okay, so that's the end of the first video. Hope you enjoyed it. If you have questions, make sure to ask your teacher before your final. And that's it for today. All right, I'll go to the next one. Bye-bye. See you there.